So far, we've learned all the basic constructs of programming, variables to store values, and the various data types, including complex data types. These are the data structures that we use to store data. We are now ready to step into real programming. We'll start off by looking at how we can check conditions within our program with the if-else statement. Programming is all about making decisions based on the various conditions that you're evaluating. If-else statements help us make those decisions, and based on the condition that we've evaluated, it'll help us take those appropriate actions. What are conditions? Conditions are statements which return true or false. Is 1 greater than 0? We all know the answer to this. This is true. Is 45 less than 99? Yes, these are both positive numbers. This is true once again. Conditions return Boolean values. Is 45 greater than 99? The answer to that is false. Conditions in Python can be more interesting and can involve functions as well. Here we invoke the built-in function len to find the length of a string and see whether the length of that string is greater than 10. The length of hello is not greater than 10, so we get false. We can make things more interesting. Conditions can evaluate whether the maximum value in the list specified is less than 100. The list contains the elements 1, 3, 5, 2, and 9. The maximum is 9. Yes, indeed, it's less than 100. This condition evaluates to true. In addition to greater than and less than, Python also supports the conditional operators greater than equal to, less than equal to, and not equal to. 9 is greater than equal to 9. This condition evaluates to true, as you might expect. 8 is less than equal to 8. This condition evaluates to true as well. Conditions can be used to evaluate equality as well, but in that case, Python uses the double equal to symbol. This is extremely important. The single equal to is for assignment. The double equal to is for evaluating equality. We are familiar with the single equal to assignment operator, where we perform some computation and store the result of that computation in a variable. That's where we use the single equal to. When we want to evaluate equality, as you see on screen, you'll use the double equal to. What we want to do here is to check whether 6 modulo 3 is equal to 0. We want to see whether 6 is perfectly divisible by 3 and has no remainder. If the remainder is 0, 6 is divisible by 3. This condition evaluates to true, as you might expect. Now, if you were to use the assignment operator instead of the double equal to for equality evaluation, you'll get an error in Python. The single equal to here is wrong because you can't assign to the left hand side. You can't assign to 6 modulo 3. That's not a variable. And the error you get is fairly clear about this. It's a syntax error. You're using the wrong syntax for conditional equality evaluation. You can't assign to the modulo operator. You can swap the right hand side and the left hand side when you're performing conditional equality checks. This is the same equality check that we've seen before. We want to know whether 6 divided by 3 has a remainder or not. 6 modulo 3 is indeed equal to 0. This condition evaluates to true. Using the double equal to when you perform conditional equality checks is extremely important, especially when you're using variables. Here, A double equal to B basically checks whether the values stored in A and B are equal. This is a conditional equality check. But a teeny little change here, A equal to B, completely changes the nature of this statement. This is an assignment operation. Your Python interpreter will take the value of B and store it in the variable A. Completely different from the conditional equality check. So make sure you're very careful. Now that we've understood how to evaluate conditions, we are ready for our first programming statement, the if statement. We have some number which stores the value 10, and we write an if statement which checks whether some number is less than 20. If this condition evaluates to true, then we will print out the number is less than 20. Now, how does Python know that the print statement has to be executed only if the condition evaluates to true? Python understands this because of the way the indentation has been set up. Notice that the print statement is indented within the if statement. This indentation basically means that the print statement will be executed when the condition evaluates to true. The print statement is part of the if block. Notice the colon at the end of the if statement. This is extremely important. The colon signifies the start of the if block. If you try to write the if statement without a colon, that will be an error in Python, a syntax error. The value stored in some num is 10. 10 is less than 20. The if condition evaluates to true, which is why the print statement is executed. The number is less than 20 is printed to screen. Let's say that we flipped the conditional check. We check whether some number is greater than 20 and then print the number is greater than 20 if this condition evaluates to true. This condition is clearly false, which is why nothing is printed to screen. Your if block can hold multiple statements that will be executed when your condition evaluates to true. Notice we have 3 print statements within our if block. They all have the same indentation. Statements which are indented to the same level form a block of code. So if some number is less than 20, all 3 of these print statements will be executed. And you can see that is indeed the case. What we just saw was the extremely simple if statement. The if statement can be paired with an else for branching into 2 conditions. If some number is less than 20, you want to take some action that will be below the if statement. Otherwise, you want to take a different set of actions. Those statements will be in the else block. If some number is less than 20, we'll print the number is less than 20, else we'll print the number is greater than 20. Notice the colon at the end of the else. That signifies the start of the else block, and the indentation includes all statements which are part of the else block. Here it is just the one print statement. Because some number is less than 20, only the statements within the if block will be executed. The statements in the else block will not be executed. On the other hand, if the condition had evaluated to false, that is some number was indeed greater than 20, then we'll only execute the statements in the else block, not the statement in the if block. Let's change the value that's stored in some number. We'll assign the value 34 to it and then rerun a bunch of if statements. We'll make the if statements progressively more complicated. You'd be right to think that there is a lot going on here, but don't worry, we'll parse this bit by bit. Let's start off with the first if statement. The first if statement checks whether some number is greater than equal to 0 and less than 50. If this condition evaluates to true, we'll print the number is between 0 and 50. If the number is not between 0 and 50, we will move into the elif statement. The elif is short form for else if. In this elif statement, we'll check whether some number is greater than equal to 50 and whether it's less than 100. And if this is true, then we will execute the statement print the number is between 50 and 100. If the first 2 conditions both evaluated to false, we'll move into the next elif statement where we check whether some number is greater than equal to 100 and whether it's less than 200. If this condition evaluates to true, we'll print the number is between 100 and 200. And then finally, if all of the first 3 conditions evaluated to false, we'll enter the next elif statement where we'll check whether some number is greater than or equal to 200 and less than 300. If this condition evaluates to true, we'll print the number is between 200 and 300. As you can see, you can chain together if-else conditions using the elif command. The most important thing to understand here is that the conditions are checked in the order that they appear in the statements. We first check the condition for the first if, then for the first elif, then for the next elif, and then for the third elif. In our case, some number is 34, which means the number is between 0 and 50. The first condition evaluated to true, we won't enter any of the other elif blocks. The result of a conditional evaluation is either true or false, which is why it should be no surprise to you that you can use booleans when you use your if conditions. So let's say we have the variable active, which we assign to false. You can use this boolean variable in an if check. If not active, print this account is not active, because active is false, not active will be equal to true. This condition will evaluate to true, and this account is not active will be printed. As we've seen before, you can use the logical and or not operator within the if statement as well. Here, if some number is greater than 50 or not active, we can say one of these conditions has to be true for the print statement to be executed. The condition in the if statement evaluated to true, which is why the output was the print statement that you can see on screen. Let's see why that is the case. Let's first check some number greater than 50. Is that true? No, it isn't, because some number is 34. That's what we had initialized it to. But active is equal to false, which means not active is equal to true. One of those conditions is true, which is why that statement was printed on screen. You can also evaluate expressions in your if statement. Here we've initialized the num variable to 7, and then in our if statement we check whether num modulo 2 is equal to 0. Num modulo 2 is an expression. We use the double equal to for conditional equality checks. Num modulo 2 is equal to 0. That will not evaluate to true, that will be false, which is why we'll go into the else block, and the statement that will be printed to screen will be the number is odd. Here is a simple equality check. Check whether number is equal to 7. This is obviously true. That's why we get you win on screen. Now, Python is really helpful and tries to not let you make mistakes. If you use the single equal to when you're evaluating an if condition, Python will throw an error and say, this is invalid syntax. Remember, the single equal to is for assignment, not equality checks. The operator not equal to is represented by an exclamation mark followed by an equal to. If number not equal to 8, print the number is not 8. Since the variable num is 7, this condition evaluates to true, which is why the statement is printed. There are some special checks that we can perform with lists using the if statement. Here we have a list of students: Ayaz, Atira, Deb, and Priya. Sometimes in a program, you might want to check whether the student Ayaz is part of this list. Because if you try to access Ayaz without it being part of a list, that might lead to an error condition. There is an easy way to do this in Python. If Ayaz in student list, the in statement allows you to check whether an element is present in the list. This condition evaluates to true, which is why we get the printed output, yes, he is a student at this school. We can now check whether Anu is part of this list. If Anu in student list, this condition evaluates to false, which is why there is no printed output to screen. The use of the in operator is not limited to lists. You can use it with dictionary keys as well. Here is a dictionary of math scores for Ram, Kumar, Kishan, and Natasha. Here is an if statement to check whether the student Ram is present as a key in this dictionary. If Ram in math scores will automatically look at the keys of this dictionary and check whether Ram is a valid key. In this case, Ram is indeed present in the dictionary, which is why the statement is printed as an output to screen. We can also look for non-existent keys. If Ayub in math scores, we'll print, yes, I do have scores for Ayub, but Ayub is not a valid key in this dictionary. This conditional statement will evaluate to false, and the print statement will not be output to screen.